Hey everyone, in this video I will be going over how to solve three variable systems of equations. So taking a look at my learning target, I can solve a three variable system of linear equations. Pretty straightforward for this one. So when solving three variable systems of equations, our goal is to break it down into a two variable system because at this point we already know how to solve two variable systems and we've got multiple strategies. We could graph by hand, we could use elimination, substitution, or Cramer's rule. Once we solve the two variable system, we can plug our solutions into one of our original equations and solve for the third variable. So for three variable systems of equations, even though we could use a few different strategies, the main one we're going to use is elimination. Okay, so let's zoom in and take a look at our example. So our example here, we've got three equations with a max number of three variables. Okay, so it's not like we can have four variables and three equations. That's not quite gonna work for us. Okay, so three equations, three variables, those variables being x, y, and z. So the first thing that I want to do is I want to pick two equations and eliminate a variable. Okay, which we already actually know how to do at this point. So taking a look at my three equations, my bottom two, so my middle one and my bottom one, I've got a positive 4x and a negative 4x. I know my x's are going to eliminate. Okay, so what I am going to do is I am going to combine those two equations and eliminate my x. So 4x minus 4x cancels out, it eliminates, and I am left with 8y. 2z plus 6z is going to be 8z. And negative 15 minus 1 is going to be negative 16. So I am not going to do anything with this equation quite yet, but I'm going to put a star next to it just so I don't forget about it. Okay, I don't want to lose track of this. So I like to call this one of my starred equations. Okay, from here what I'm going to do is I'm going to pick two other equations. So I pick the middle and the bottom to get my first equation. I'm going to pick two others and also eliminate x because that'll give me another equation in terms of y and z, which would then give me a two variable system that I can solve. So I am going to choose the top equation and the middle equation, and I'm going to eliminate x. So I am going to need to scale my top equation by 4. So when I do that, I am left with negative 4x minus 4y minus 16z equals 4. And then my middle equation, I'm just going to rewrite underneath it. So I've got 4x plus 3y plus 2z equals negative 15. So now I'm going to combine these two equations. When I do that, my x's eliminate, and I am left with negative 4y plus 3y, which is just negative y, or negative 1y. Negative 16 minus 2z is going to be a negative 14z. And 4 minus 15 is going to be negative 11. So same thing, I'm going to put a star next to this equation because this is one of the equations that is going to make up my two variable system. So speaking of my two variable system, I'm going to take these two starred equations and I'm going to stack them on top of each other and prepare to solve them. Just putting them in a familiar format, if you will. So my first starred equation was going to be 8y plus 8z equals negative 16. And my bottom start equation is this second one that I found. So I've got negative y minus 14z equals negative 11. Okay, so I am going to solve this two variable system, and I'm going to use elimination, and I will choose to eliminate my y. So I will scale this bottom equation by 8 in order to get a coefficient of negative 8 for my y value. So if I rewrite my equations over here, my top equation does not change. But my bottom equation becomes negative 8y minus 112z equals negative 88. I will combine these two equations, eliminating my y. When I do this, y's are gone, and I get 8z minus 112z, which is going to be a negative 104z, equals negative 16 minus 88, which is going to be negative 104. So at this point, what I can do to isolate my z, I can divide both sides by negative 104. One hundred four is eliminate, so I end up with z equals 1. Okay, so at this point what I can do, I can take this 1 that I found for z, plug it into one of my original start equations here, and solve for y. Okay, so I am going to pick, let's do my top equation here. So I'm using the top star equation. So all right, top star and it's going to look like this. 8y plus 8, instead of z, I'm plugging in a 1. Equals negative 16. Okay, so if I simplify this, I have 8y plus 8 equals negative 16. I will subtract 8 from both sides. When I do that, eights cancel, and I am left with 8y equals negative 24. To isolate that y, what I'll do is I'll divide both sides by 8. Eights cancel on the left side. So I end up with y equals negative 24 divided by 8, which is negative 3. Okay, so now that I know what z is and I know what y is, I've solved my two variable system, I can pick one of my two original equations up here, plug 1 in for z and negative 3 in for y, and solve for x. So I'm going to choose my middle equation. So I'll do that right over here. If I write my middle equation, I've got 4x plus 3, but instead of y, I'm plugging in a negative 3. Plus 2, instead of z, I'm plugging in a 1. Equals negative 15. Okay, so this is just my original middle equation. If I go ahead and simplify this, I get 4x. 3 times negative 3 is going to be negative 9. 2 times 1 is going to be positive 2. My equal sign and negative 15. So if I continue to solve this, I can combine my numbers on the left side. So I end up with 4x. Negative 9 plus 2 is going to be negative 7 equals negative 15. I can add 7 to both sides. When I do that, sevens eliminate, so I get 4x equals negative 8. Scroll down a little so I don't run out of space. Divide both sides by 4 to isolate that x. Those are gone on the left side, so I end up with x equals negative 2. Okay, so for my system of equations down here, or as my ordered triplet, if you will, I got negative 2 for x, negative 3 for y, and 1 for z. So that's how I would be looking for your answers. Okay, so if we just go and recap this really quick, we had a 3-variable system. We picked 2 equations. Okay, in this case it was the bottom 2 to start off, and we eliminated a variable. From there we picked 2 different equations and eliminated the same variable. It has to be the same. From there we were given 2 start equations that created our 2-variable system that we were able to solve. We ended up with 1 for z, negative 3 for y. We took those solutions, picked one of our original equations. In this case we picked the middle one, plugged in negative 3 for y and 1 for z, solved, and got our x. Therefore, we finally had our ordered triplet here of negative 2, negative 3, and 1. Okay, let's move on to some more examples. All right, so taking a look here. All right, we need to pick a variable to eliminate. So, I don't know, let's try to eliminate our z's, okay? Because we can already do the bottom 2 equations and we'll be all set. So, to eliminate our z's, they are gone. Negative 6x minus 4x is going to be a negative 10x. Negative 6y minus 5y is negative 11y. And negative 26 plus 19 is going to be a negative 7. So I now have equation in terms of x and y. I'm going to put a star next to this so I don't forget about it. Okay, so now I need to pick 2 other equations and eliminate z again. So how about I do the top 2 equations? So I've got a 5z and a negative 4z. The smallest number that they both go into is going to be 20. So I am going to multiply my bottom equation by positive 5, and I'll multiply my top equation by positive 4. So when I do that, I end up with negative 20x up top, minus 8y, plus 20z, equals 44. And down bottom I get negative 30x minus 30y minus 20z equals 26 times 5 is going to be negative 130. So I'll combine these two equations. When I do that, my z's will eliminate. Negative 20x minus 30x is going to be a negative 50x. Negative 8y minus 30y is going to be negative 38y. And 130, or 44 minus 130 is going to be a negative 86. And I'm going to put a star next to this equation as well. So now I can use my two start equations and solve my two variable system. So I will write those down here. So I've got my first start equation, my second start equation, now I'm just rewriting them. So I'm going to continue to use elimination, and if I'm taking a look at my variables, or the coefficients of my variables, it looks like y will probably be my best bet. So if I make this negative 10y a positive 50y, my y's will eliminate. So I'm going to scale my top start equation by negative 5. And when I do that, I end up with positive 50y plus 55. Oh, sorry. I've got a small issue here. I've got way too many y's. So let me get my eraser out. Those should be x's, not y's. Got on the y train. So therefore over here I should have 50x, not y. Plus 55y. Knew something didn't look right there. Equals positive 35. And then I've got my negative 50x minus 38y equals negative 86. So I can combine these two equations. And when I do that, my x's cancel. I have 55 minus 38, which is going to be a positive 17y. Equals 35 minus 86, which is going to be negative 51. I can divide both sides by 17. Seventeens cancel on the left, so I am left with y equals negative 51 divided by 17, which is going to be negative 3. Okay, so I've solved for one variable, so I can take this variable and plug it into one of my start equations and solve for my other variable. So in this case, I have y, I'm able to solve for x now. So I am going to pick I'll do my top start equation here. So I'll write top star. So when I have my top start, or write down my top start equation, I'm going to have negative 10x minus 11. Instead of y, I'll plug in a negative 3 equals negative 7. So if I simplify this, I'm left with negative 10x plus 33 equals negative 7. I can subtract negative 30 or subtract 33 on both sides. When I do that, I am left with negative 10x on the left side. And on the right side, I get negative 7 minus 33, which is going to be negative 40. I can divide both sides by negative 10 to isolate my x. Negative 10's cancel on the left. So I am left with x equals negative 40 divided by negative 10, which is going to be a positive 4. Okay. So I took this negative 3 for y, I plugged it into my top start equation, and I was able to solve for x. So now I am going to take my x and my y, pick one of my original equations, and solve for my z. Okay, so if I take a look at my three equations here, it doesn't matter which one. Per usual, you should still get the same solution no matter which one you choose. It's actually a good exercise to use multiple equations to check and make sure you're getting the same answer for all of them. So I am going to use the top equation. So if I rewrite the top equation but plug in some variables here, I get negative 5. But instead of x, I'm plugging in 4, because I now know what x is. Minus 2. And instead of y, I'm going to plug in negative 3. And then plus 5z equals 11. Okay, so if I combine some stuff here, negative 5 times 4 is going to be negative 20. Negative 2 times negative 3 is going to be a positive 6. And then I've got my plus 5z, which I didn't touch yet, equals 11. So I can take my negative 20 and add 6. When I do that, I get negative 14 plus 5z equals 11. I can add 14 to both sides. When I do that, 14's cancel on the left. So I am left with 5z equals 11 plus 14, which is going to be 25. I can divide both sides by 5 to isolate my z. They cancel on the left, so I end up with z equals 25 divided by 5, which is going to be 5. So my solution to this three-variable system of linear equations is going to be the point 4, negative 3, 5. Okay, so now I'm going to move on to my next example. Okay, so for this example, it looks a little bit different because this bottom equation here does not have three variables. It only has two variables. Okay, and that's completely okay, as long as it doesn't have more variables than we do equations. If this had 4, 5, 6, 7 variables, then we'd be in a little bit of trouble. We wouldn't be able to solve it. But if we have 2 or 1, that's totally okay. So because this only has two variables and I'm trying to find a two-variable system, I'm going to put a star next to this. Okay, it's already in the perfect format for me. So this will be one of the equations I use in my two-variable system. So because this two-variable equation is missing a z, if I take my other two equations and eliminate z, I'll have my second start equation. So my coefficients for z are positive 3 in the top equation and negative 6 in the middle equation. So if I scale this top equation by 2, I would be able to eliminate my z's, which is exactly what I want to do. So if I rewrite my top equation after I scale it by 2, I have 4x minus 2y plus 6z equals negative 14. And then my middle equation, I'm not changing at all. So I'll just rewrite it. Negative 5x minus 3y minus 6z equals negative 2. So I can combine these two equations, eliminating my z's. 6z minus 6z, gone forever. 4x minus 5x is going to be a negative x. Negative 2y minus 3y is going to be negative 5y. My equals, and negative 14 minus 2 is going to be negative 16. So I'm going to put a star next to this equation as well, because I can now take these two starred equations and solve my two variable system in terms of x and y. So I am going to just rewrite my two starred equations. Pick a different color. So I've got negative x plus y equals 2. And then my second starred equation is negative x minus 5y equals negative 16. So I'm going to use elimination, taking a look at my variables x or y. I think it's going to be a little bit easier to eliminate my x's, so I need to make one of those a positive x to make that happen. So I'm going to scale my top equation by negative 1. So when I do that, my top equation, all the signs are going to flip, so it will become x minus y equals negative 2. My bottom equation doesn't change. I've got negative x minus 5y equals negative 16. So time to combine. When I do that, my x's are going to eliminate, and I am left with negative y minus 5y, which is negative 6y, and negative 2 minus 16 is going to be negative 18. So I can divide both sides by negative 6. Negative 6's cancel on the left side. So I am left with y equals negative 18 divided by negative 6, which is a positive 3. Okay, so I can take this 3 and plug it into one of my starred equations and solve for x. So I am going to choose my, let's do my top star. So for my top star, I can rewrite as negative x plus 3 equals 2. I can subtract 3 on both sides. When I do that, I end up with negative x equals 2 minus 3, which is negative 1. So here I can divide both sides by negative 1 to make that x positive. So I get x equals negative 1 divided by negative 1, which is going to be a positive 1. So now I've got two variables. I can take those two variables and plug them into, well, my options are a little bit more limited here, a little bit more strict. I can pick my top equation or my middle equation and solve for z. So I'm going to take my top equation. So let me write that. So my top equation is going to be 2. Instead of x, I'm plugging in a 1. Minus, instead of y, I'm plugging in a 3. Plus 3z equals -7. So I'll scroll down and solve this. 2 times 1 is going to be 2. I've got this -3 plus 3z equals -7. I can combine my numbers on the left side. So when I do that, I get -1. And then I'll bring down my plus 3z and my -7. I can add 1 to both sides. When I do that, 1's cancel out, so I get 3z equals -6. Divide both sides by 3. So z is going to equal -2. Okay, so the solution to this system of equations is going to be 1 for x, 3 for y, and -2 for z. Okay, we've got a couple more left. Hopefully by this point we're starting to get the hang of it a little bit. So taking a look at this system right here, I've got my variables have changed a little bit. They're in terms of r, s, and t. That is no big deal at all. It doesn't matter what our variables are or what unknowns we're trying to solve for. It really doesn't impact what we're doing. So if I take a look at these right here, it looks like my t's are going to be my best bet to eliminate here. So what I am going to do is I am going to start with my bottom two equations. So I've got a -4t right here, and I've got a positive 2t. So if I scale this middle equation by 2, I will make this 2t a positive 4t, which will allow me to eliminate my t's. So if I rewrite these, I get -6r minus 4s plus 4t equals -14. And my bottom equation I'm just rewriting. So -5r minus 3s minus 4t equals 2. So I can combine these two equations. When I do that, my t's eliminate. -6r minus 5r is going to be a -11r. -4s minus 3s is going to be a -7s. And -14 plus 2 is going to be a -12. So this is going to be one of my start equations. Okay, so now I'm going to pick two other equations and also eliminate t. So if I take a look at which equations I should pick, I'm going to choose my top and my bottom because I've got a t up top and a -4t down bottom, which means I can just scale my top equation. I can get away without having to scale my bottom equation. So I am going to scale my top equation by 4 and combine it with my third equation. So I've got my first and my third. So for my first equation, I've got 16r after I distribute the 4 plus 8s plus 4t equals 4, or 16, sorry. Can't mess that up, got to be very thorough with our math, make sure we're checking everything as we're going along. And my bottom equation is going to be negative 5r minus 3s minus 4t equals 2. I know that I can combine these two equations. When I do that, my t's eliminate. 16r minus 5r is going to be 11r. 8s minus 3s is negative 5s. And 16 plus 2 is going to be 18. So this is going to be my other start equation. So what I'm going to do now is I'm going to stack my start equations and solve the two variable system that I have. So if I write my equations, I've got 11r minus 5s equals 18. And I've got negative 11r minus 7s equals negative 12. Okay. One quick thing, I am taking a look at this. I knew something didn't look right. I made another little mistake that I want to cover. I had this positive 8s minus 3s. That's not going to be a negative 5s. That's going to be a positive 5s. So I've got to change this to a plus sign. Very minor, but those are the types of mistakes where you just get one wrong negative sign and it throws a wrench in everything. It will impact your final answer, and you'll drive yourself crazy going back trying to figure out where your mistake was. Everything will look right, but there will just be one positive or negative hiding there, or one little arithmetic error that's going to change everything. So just be very careful, like I have just now, that as you're doing this, you're taking a second and a third look at things. You're not waiting until the end of the problem to check all your math. Okay, so now if I combine these, no scaling's required here. My r's are going to eliminate because my coefficients are 11 and negative 11. If I keep going down, 5s, positive 5s minus 7s is going to be a negative 2s. And 18 minus 12 is going to be 6. I can divide both sides by negative 2. When I do that, negative 2's cancel on the left side, and I am left with s equals 6 divided by negative 2, which is going to be negative 3. Okay, so now I can take this negative 3 and plug it into one of my start equations and solve for r. So I'm going to pick, let's do my top start equation. So I'll do that right here. So top star. So my top star is going to look like this. I've got 11r plus 5. Instead of s, I'm plugging in negative 3 equals 18. Okay, so if I simplify, I have 11r. 5 times negative 3 is going to be negative 15 equals 18. I can add 15 to both sides. Okay, when I do that, fifteens are going to cancel on the left side, and I am left with 11r equals 18 plus 15, which is 33. I can divide both sides by 11 to isolate my r. 11's cancel on the left, So I am left with r equals 33 divided by 11, which is positive 3. So now I have my r, I have my s, now I need to solve for t. So what I am going to do is I'm going to pick one of my original equations. I'm going to do my top one again. So I've got my top equation, which is 4. But instead of r, we are plugging in 3. Plus 2. Instead of s, I'm plugging in negative 3. And then plus t equals 4. So I'm going to scroll down and solve this. 4 times 3 is going to be positive 12. 2 times negative 3 is going to be negative 6. And I've got my plus t equals 4. I can combine this 12 and this minus 6, which is going to be a positive 6, plus t equals 4. I can subtract 6 on both sides. When I do that, 6's cancel on the left, and I am left with t equals 4 minus 6, which is negative 2. So my solution to this three-variable linear system of equations is going to be the point. Even though I have x, y, z here, just do it in alphabetical order. So it's going to be r, s, t. It's going to be 3, negative 3, and negative 2. Okay, one more problem left. We're almost there. I realize this has been a long video, but these are some dense problems that we're dealing with. Okay, so taking a look at this system, I'm back to x, y, and z. Again, variables don't matter. I am going to choose to eliminate my, looks like x is going to be my easiest. I'm never going to have to scale both equations. So I'm going to scale my bottom equation. I'm going to scale it by 2 in order to get my coefficient of x as negative 4, because my x's will then be able to eliminate. So when I do that, I'm going to rewrite my middle equation. So I've got 4x plus 3y plus 4z equals negative 2. And then my scaled bottom equation is going to be negative 4x minus 2y minus 10z equals negative 16. I can combine these two equations. When I do that, my x's eliminate. I am left with 3y minus 2y, which is a positive 1y. 4z minus 10z is negative 6z. And negative 2 minus 16 is going to be a negative 18. I'm going to put a star next to this equation so I don't forget about it. All right, so now I need to pick 2 other equations and also eliminate x. Okay, so I am going to pick I'm going to do my first and my third equation. Okay, I'm taking my original third equation here, so the coefficient as negative 2x, or my coefficient is negative 2 rather. So I am going to scale my top equation by positive 2. Okay, so I'll do that right down here. So I've got my top, and I've got my bottom. So when I write these two equations, my scaled top equation, once I distribute that 2 is going to be 2x minus 2y minus 4z equals 8. And my original bottom equation is negative 2x minus y minus 5z equals negative 8. I'm now able to combine these two equations. When I do that, my x's eliminate. I'm left with negative 2y minus y, which is negative 3y, negative 4z minus 5z, which is negative 9z, and 8 minus 8, which is 0. So this is going to be my other start equation. Okay, so I'm going to write my two start equations down here a little further and prepare them for the elimination process again. So my top equation is going to be y minus 6z equals negative 18. And my bottom one is going to be negative 3y minus 9z equals 0. Taking a look at this, it is probably easiest to eliminate my y's. So I need to scale my top start equation by positive 3 in order to give that a coefficient of positive 3. So when I do that, I'm going to have 3y minus 18z equals negative 54. My bottom equation I'm just rewriting, negative 3y minus 9z equals 0. I will combine these two equations, eliminating my y. Negative 18z minus 9z is going to be a negative 27z. And negative 54 plus 0 is going to be negative 54. I will divide both sides by negative 27. So I get z equals negative 54 divided by negative 27, which is a positive 2. So I can take that 2 for z and plug it into one of my start equations and solve for my y. I am going to do the, let's do the top star. So the top star is going to be y minus 6. Instead of z, I'm plugging in 2. Equals negative 18. If I simplify, I get y minus 12 equals negative 18. I can add 12 to both sides. When I do that, 12s cancel on the left. So I get y equals negative 18 plus 12, which is going to be negative 6. So from here, I need to pick one of my original equations, plug in negative 6 for y, 2 for z, and I'll be able to solve for x. So I am going to do my, let's do my top equation. No, let's do my middle. We'll switch it up a little bit. So I am running out of room here. I'll find some space. So if I do my middle equation, I've got 4x plus 3. Instead of y, I am plugging in negative 6. Plus 4. Instead of z, I am plugging in 2. Equals negative 2. So if I combine, I end up getting 4x minus 18 plus 8 equals negative 2. I can combine the negative 18 and the positive 8. When I do that, I get 4x minus 10 equals negative 2. I can add 10 to both sides. When I do that, 10's cancel on the left. So I get 4x equals negative 2 plus 10, which is 8. Divide both sides by 4. So x is going to be positive 2. So the solution to this system of equations is going to be 2, negative 6, and positive 2. Okay. At this point, you should be ready for some practice. As usual, let me know if there's anything I can do to help you, or if you need any additional practice or example problems. I would be happy to get some for you. Have a great day, everyone.